Good morning, I'm Peter VK3YE and we'll shortly be doing a presentation on fun with QRP for those at the Wyong Field Day today and also those watching at home. I will take questions afterwards in probably about an hour's time, as that's about the length of the presentation. If anyone is at the Wyong Field Day, then please let me know in the comments. I won't be looking at the comments while I do the presentation, but will do so afterwards to answer any questions. This will be a general video. It's called Fun with QRP. So I'll go through various aspects of QRP and what you can do, how you can get started, the sort of results that you can expect. Okay, and we have a comment from the Central Coast Amateur Radio Club, who is hosting today's Wyong Field Day. About 5 minutes behind schedule, so we'll be starting in approximately 6 minutes. In the meantime, for others watching, enjoy these pictures. In case you're not hearing any sound, it's because I'm not talking. The presentation will begin in approximately 4 minutes. You're about to watch a presentation called Fun with QRP by myself, Peter VK3YE, prepared for today's Wyong Field Day. The presentation will start very soon, in about 2 or 3 minutes. You'll shortly be hearing a presentation called Fun with QRP, presented for the Wyong Field Day. Hello to those at the field day and those listening elsewhere via YouTube. We'll start shortly. One of the door prize items at today's Central Coast Field Day is the Australian Ham Radio Handbook. All you need to succeed in amateur radio in Australia. If you're not lucky enough to get the door prize, you can pick up one of these books in your nearest J-Car shop or order via their website. It's $24.95 and great value for those in amateur radio in Australia. This is a presentation on Fun with QRP and will be starting very soon. If you're wondering what this is, you've just turned on to a presentation where I'll talk about Fun with QRP for the Central Coast's Amateur Radio Club Wyong Field Day. We'll start very soon, just waiting for the go-ahead. Hello, I'm Peter VK3YE, and shortly I'll be giving a presentation for the Wyong Field Day on Fun with QRP. The previous presentation is still talking, so we'll wait for them to wrap up and we'll begin this presentation. In the meantime, enjoy these pictures of various homebrew and kit QRP equipment. This is Peter VK3YE, and I'm about to start a presentation on fun with QRP for the Wyong Field Day. The previous presentation is still going, so I'll be starting shortly. This is Peter VK3YE, and I'm about to start a presentation on fun with QRP. The presentation will start fairly soon. We're just waiting for the previous speaker to conclude. Okay, this is a audio test for the Central Coast Amateur Radio Club. This is a audio test for the Central Coast Amateur Radio Club in preparation for a presentation that will start shortly on Fun with QRP. I'm Peter, VK3YE. If you're not aware of it, this is the Australian Ham Radio Handbook, Australia's only handbook that covers many aspects of amateur radio. If you're just getting back into the hobby, or if you're new to it, then you'll find a lot of detail about local amateur radio activity. Make sure you've got your ticket ready for when the door prize is drawn at the Wyong Field Day, or if you're unlucky enough not to win it, then just pop into your J-Car shop and you'll be able to find it. Or go on their website and order it. It's just $24.95 and you'll be able to get a handbook just for Australia and amateur radio. And thanks to the Central Coast Amateur Radio Club, we're about to start. Okay, hello to everyone who's at the Central Coast Amateur Radio Club and those who are listening and watching at home via YouTube. I'm Peter, VK3YE, and today's topic, Fun with QRP. Well, what is QRP? First thing, it's one of those three-letter Q codes. You might have had to study for your amateur exam. QRP basically means shallow reduced power or low power, and we're talking about transmitter output power. There's no hard and fast definition, but most people regard under 5 watts as being QRP on CW and digital modes, or for SSB under 10 watts. So that's QRP. Low power, pretty much foundation license condition power levels for SSB, bit less on CW and digital modes. And pretty much almost any amateur activity can be done with QRP, and some activities are even best with QRP. There's a lot of reasons why you'd want to operate QRP. Despite claims of bad band conditions, people say they can't hear much, they can't work much. Why would you want to operate QRP? Surely more power would allow you to get better results. Well, not necessarily. There's a certain challenge with using low power gear. You might have already made lots of contacts with 100 watts and it all seems too easy. Then, well, try and do it all again. Maybe DXCC or some award with QRP. It's really easy to build homebrew stuff with lower power. You're not having to worry about high current power supplies, or there's fewer problems with RF feedback and those sorts of issues that can sometimes be difficult to track down if you're building high power amplifiers. And the mechanical construction is a lot easier if you're only dealing with low voltages and currents. So QRP can be much easier to build stuff for, and you can assemble a QRP project in an afternoon or a weekend and be on the air. It's also great for portable operating. So to national parks. Not sure about the weather up there, but it's great down here in Melbourne and fine and sunny, but you don't want to be lugging heavy gear up to a mountain into a national park or whatever. If you've got low power, then you don't need much in the way of transceivers or power supplies or heavy batteries. Just something light will keep you going for hours at a time, all possible with QRP. Then there's weak signal data modes. They're particularly effective. They can be 20 or more decibels more effective than SSB. Again, you don't need a lot of power to succeed there. Also, there are certain awards like Summits of the Air or National Parks where it's better that you are portable at summits or peaks and or parks, and QRP is really easy to take equipment to. And then you've got HF Pedestrian Mobile, which I might talk about later on if we've got time. But that's something where you're having your equipment needs to be very light as you're carrying everything. You don't have a vehicle or in some cases even a cart to put stuff in. So you're having to carry your own equipment, including the power source. And it's great fun to be operating pedestrian mobile with QRP. Now, does QRP really work? I mentioned the bad conditions before. You might hear people moaning about, we're supposed to be at the bottom of the solar cycle and the conditions. Well, it's probably easiest to make, you can still make worldwide contacts with QRP, even on SSB, even at this phase of the solar cycle, but it's probably a bit easier on CW and even more easy on digital modes, which offer a great advantage in signal to noise ratio. But even if digital modes don't float your boat, contacts within VK and ZL are very easy to achieve with QRP on bands like 80, 40, 20 meters. So up to around 3,000 kilometers with 5 watts SSB, then you can still do very well. You can also have success with portable operating, especially if your portable operating site is better than what you have at home. I mentioned equipment you can build yourself. Again, great possibilities there. Now, what sort of QRP equipment might you use? There's a wide choice. You can buy new, you can buy secondhand, you can build from a kit, or even build from scratch. Probably the most popular rig, and you'll probably see people at the field day to day with them, the FT817 by Yaesu, or the newer FT818. Pretty much identical. They are a little 5-watt package, 160 meters through to 70 centimeters, all modes. If you're wondering what type of QRP equipment to get, then the FT817, 818 is a great general purpose package. It's very robust. One thing I wouldn't trust though, the internal battery. The FT817s came with a really small internal battery. The 818 isn't a lot better, so I personally prefer to use external batteries, and I'll talk a bit more about batteries later on. But yeah, maybe not the ultimate in receive performance, but overall, there's very little that you can, cases where that's a limitation in practice. So if you want a bit of everything, the FT817, 818 is a great choice to start off with. Then costing a little bit more are Elecraft rigs. There's an Elecraft KX3, which is about the size of a house brick, maybe about half its height, and a smaller version, the KX2. I think the KX2 has fewer bands, KX3, some more bands, a bit more expensive. It's a bit better receiver, a bit more output power. It draws less current on receive. So if you're after something that's really good receiving performance, then the Elecrafts can be great. However, they don't have quite as many bands as the FT817, and also I reckon they're less robust. If you've ever looked at a Elecraft KX3, no doubt there'll be someone at the field day today who will have brought one along. I reckon it's a bit like Swiss cheese. It's got more holes in it than, say, the FT817. So if you're going to be taking your rig outdoors where it's blowing a gale, there's sand blowing from the beach, I think the FT817 is a bit more robust. On the other hand, if you're the type that really looks after their gear, then the Elecraft is probably okay and gives you some better performance. Then there's the possibility of older type of QRP rigs. Now, when you're going around the junk sale, people, some of the best bargains might have already gone. It's nearly midday, but you never know. You might still find something there as you go around the car park sales. Anyway, the ICOM 703, it came out in the 90s. It looks a lot like the ICOM 706, which was a very popular mobile rig back in the mid-90s. But the ICOM 703 is the QRP version. It's got quite a good receiver, possibly better than the FT817. It's 160 through to 6 meters. So if you're into HF QRP, it's good. It is, however, quite heavy, and it's got more receive current drain than the FT817. So if you're looking for a QRP rig for home, Maybe it doesn't have the sort of finicky menus that some people don't like with the FT817, 818, then the ICOM 703 is not a bad choice. Then earlier on, you've got, back to the 70s, you've got rigs like the FT817. Some people will have started in amateur radio with them. It's a very basic 80 through to 10 meter transceiver, doesn't include all the bands. It's CW and SSB, analog dial. The VFO is not a DDS or synthesizer or anything like that. It's very basic, but it's got a very nice receiver, and it is quite large and heavy. And some of them command sometimes amazing prices on eBay. I think it's all because of people reminiscing about what they started off. A lot of people's first novice rig was the FT7 in the 70s. But anyway, if you can get one at a good price, and you don't mind not having all the bands, and you don't mind the analog readout, and if you're mainly interested in CW or SSB, then the FT7 is a good rig for QRP. Then you've got some transceivers that I'd call semi-kit. Very popular one at the moment is called the Microbit X. Surprisingly low price. Comes from India, designed by a guy called Ashar Farhan, VU2 ESE. And anyway, there's a lot of Facebook groups, email groups, YouTube videos. There are different models. Some of them, some versions dropped off in their output power when you got above 20 meters or so. But if you're looking for something that will get you on the air quite cheaply for say 80, 40, 30, 20 meters, the Microbit X is not a bad choice of QRP rig. Its received current consumption is quite small. When you get the kit, it's doesn't necessarily come with the box. You're getting a board. The board has all the surface mount components on it. In fact, all the parts are mounted on the board. So your main involvement when you're putting the thing together is to wire up the potentiometer, the rotary encoder for the DDS VFO, antenna socket, power socket, all that sort of thing. You can probably get one on the air in about 2 hours of construction. So not a bad rig if you're after something quite light and portable for QRP. You will have to do something about the box. It doesn't come with the box as such, but there are some cases that you can buy for it. But yeah, there's some groups on Facebook and that will help you with the Microbit X. There is, if you want something straight off the shelf that will go straight away, then maybe something like an FT817 might be better. But if you like tinkering with things, if you like getting into the Arduino-based software of it, then something like the Microbit X is a very low price and is something certainly worth having a look at. Then we have, there are also kit-type QRP rigs. And in fact, some of them are designed and manufactured, put together here in Australia. The one I'm holding right now is called the MDT. It comes from Oz QRP, which is Leon VK2 DOB. And I did a review on it on a previous video. It is double sideband, 40 meters. It covers only, I think, about a 40 kilohertz section of the band, but you can do a little mod, put in a little switch, and that will give you a bit more of the band, maybe 80 kilohertz or so. I've had some great contacts on it, as far away as VK6 and New Zealand. It's double sideband, direct conversion, not CW, it's just double sideband. And it's with a couple of watts, you can get started with a simple QRP kit. So that's one possibility. There is, however, another kit that doesn't cost very much more. It's also from Oz QRP. It's called the DCT, and that's the double sideband CW transceiver. And that's got CW as well as double sideband. It's also got a DDS VFO. It's got full band coverage, not just a segment like the MDT. And it's got a full 5 watts power output. I used one in, I think, the RD contest. I did a video of it, and it's a great little transceiver to try. Again, it's single band, but you can order it in either 80 or 40 meter version. So that's a possibility. The DCT from Oz QRP, look it up on their website. They've also got a MST3, which is a bit more advanced, That stands for Minimalist Sideband Transceiver. So you can, it's single band, but you get SSB instead of double sideband. You've also got some overseas Qrp kits like the Qrp Labs QCX from Hand Summers. A very popular kit. I think it costs around $50. Single band, that's great if you're into CW. It's only CW. There's another one coming out. I think it's called the QSX. Anyway, have a look on the Qrp Labs website. I think it's still undergoing development. So consider that as a possibility if you're more into single sideband. Then finally, one of the other kits is this Pixie. These are available at extremely low prices on eBay. I'll hold it up closer to the camera, but it's basically a simple board, 5 centimeters by 5 centimeters. As it comes, it's crystal controlled on 7 megahertz. Now, crystal controlled, as I'll mention later on, is a really big disadvantage because people are having to find your weak signal if you're calling CQ. So it can be quite difficult to get contacts. The receivers aren't great on them, and I think it's only like 200 or 300 milliamp, or milliwatts output power. So there's a lot of cases where it's going to be hard to get contacts with the Pixie. But you still can. You can still be heard over hundreds of kilometers away. You just need a lot of patience. And this particular version of the Pixie is something that I've modified. You can do all sorts of things with them. Like I converted one to an AM transmitter. I use the LM386 audio chip, although that's normally used as an audio amp on receive. I wired it differently, so it's now an AM modulator, which can modulate the transmitter section. And I built an AM transmitter on both 7 megahertz and 1.8 megahertz. Another thing you can do, you can put in a ceramic resonator. You might be able to see it, maybe not in the picture you see here. And there's a switch that switches between a crystal and a ceramic resonator. And that gives a bit of frequency agility. So if you wanted to build a little 7 megahertz receiver, then the Pixie is a possibility. Mainly, though, I'd regard it as construction practice. It's not quite ideal for if you expect to make lots of contacts, then I think you're going to be struggling. But you might be surprised if you persevere. But it is a very low price for the parts you get. So if you haven't built a kit before, then and you don't want to spend up big on something more expensive, just spend a few dollars on a Pixie, and that will give you a bit of construction and troubleshooting experience. Okay. Another thing that's come out quite recently are digital modes transceiver kits. There's a couple I can think of. There are modes like FT8 and Js8, which work quite well with QRP. There's one called the Qrp guys, double sideband digital transceiver. It's 40, 30, and 20 meters on FT8. It's direct conversion, which means that when you transmit a signal with it, you'll actually be transmitting signals on 2 frequencies, one on the desired upper sideband, the other undesired signal a couple of kilohertz down the dial. The other thing is that it's a direct conversion receiver. So if there's someone a few kilohertz away, then you might get some interference. But it's a very cheap way of getting onto digital modes using a double sideband transceiver. So that's a possibility. That goes for $40 US. It's called the Qrp guys double sideband digital transceiver. You could just hook it up to your laptop and be on the air. Another type I'd look into, I think there's a kit available for $55 US, so it's not much more expensive. And that's called the Phaser SSB digital modes transceiver. The great thing about it is, as its name suggests, it uses the phasing technique of SSB reception and transmission. So you've only got one signal on the right side of the carrier, and you're not causing interference. You've also got a better receiver because you're a single signal reception. It is, however, only mono band. I'd suggest getting one for, say, 40 meters, maybe 20 meters, but yeah, you can transmit on FT8 or JS8 depending on what crystal frequency you've got. So I'll talk a bit more about digital modes later on, but that's a possibility if you're into digital modes as a simple, cheap Qrp kit transceiver. Another thing is you can build your own from scratch. I'll show you one in a moment. Okay, this is an example. It's a 40-meter double sideband transceiver, which I've called the Beach 40. If you're looking at transceivers to build, unless it's strictly as a construction project, I'd suggest using frequencies and bands that you're likely to get a contact. And it's also easy to build gear for. 3.5 or especially 7 megahertz are very good. CW double sideband, now consider the option of a digital modes transceiver project. Have a look on the web and see what you've got. Some really simple pieces of equipment are, I think, too simple. They might be crystal controlled. They might not put out enough power. And their receivers might be quite poor. They might be overloaded by other things. So have a look very carefully at the circuits that you use. Don't avoid something that's either too simple or too complex. I've suggested some minimum requirements, particularly us here in Australia where we don't have the population density that other places do. You really need to be frequency agile. That's so important because most of your contacts with QRP are you finding other people, whether you're replying to them, they're calling CQ, and you want to respond to them, then you need to be able to move to their frequency. There might be a contact about to finish. Again, you'd only know about that if you can tune your equipment to their frequency and give them a call. You might also need to dodge frequencies to avoid interference. Again, you need to be frequency agile. And you can do that with modern DDS kits. I mentioned Oz QRP before. They've got a DDS kit. Or you can use ceramic resonators. You can get them on bands like 80 and 40 meters. Many kits over in South Australia sell them very cheaply, and you can build a 1 or 2 transistor oscillator circuit that will give you some frequency agility. So yeah, this transceiver here, it's called the Beach 40. I've got a 6-part video series, and there's also some information on my website, vk3y.com. But that will get you on the air on double sideband. It's about 2 watts on 7 megahertz. And I've had contacts up to 3,000 kilometers distance with this. It's a direct conversion receiver. It's only, I think, 6 or 7 transistors in it, not very much at all. But yeah, and bearing in mind that now with the changes to Australian license conditions, if you're a foundation licensee, then you can now build equipment like this. No longer restrictions on that, and you can also use digital modes. So that's a great benefit. Another thing as well, another rig that I've more recently been constructing, and this points to the joy of serendipity. Sometimes you can just have good luck and stuff can work out for you. For instance, if you're going through old bits of circuit boards and old TVs, computers, modems, etc., you'll very often find a crystal for 3.58 megahertz or 3.579, the American color burst crystal. Anyway, that's in the 80 meter band, which is great. Even better is that one of the new digital modes called Js8 is based very close to that frequency. Now, you might think digital modes pretty boring. Modes like Whisper, it's a great beaconing system. You can leave your transceiver to do its thing. Then there's FT8, where again you are having a very rubber stamp exchange. It's not a real. It is sort of a contact, but you're not able to chat freely. Well, JS8 is a whole lot better than that. It's a bit of a mix between, a bit of a hybrid. It reminds me a lot of slow speed CW, like 10 or 12 words a minute. It's also a bit like packet radio in that you can leave messages for people. And it's also a bit like FT8 in that your transmissions are in 15-second blocks. So you can have a transition, but the thing is that you can go beyond that 15-second block and type as much text as you want, and it's free text, so you can actually have proper keyboard to keyboard contacts. It's a bit like PSK31, except it's a bit slower, but it also means that it's a bit more efficient when it comes to low power. Anyway, what I'm holding now, featured in the current issue of Amateur Radio Magazine, January, February 2020. That article describes a very simple direct conversion receiver. It uses a 3.58 megahertz crystal, so it's good for 80 meters. And it so happens that JS8 activity is centered on 3.578. So I just put some crystals in parallel, as you can probably see there. And there's the 3 crystals there. And that has the effect of, if you put an inductor in series or a couple of inductors, that has the effect of moving a frequency down. In this case, from 3.579 down to 3.578. And that shift puts you right on the center of the activity for JS8 on 80 meters, which means that if you have a very simple direct conversion receiver, only uses maybe 3 transistors or so, you can then plug it straight into your computer's sound card, and you can be monitoring JS8 amateur activity here in Australia. And I've been able to receive signals from hundreds of kilometers away via that method. There's not as much activity as FT8, but I think it's a better mode, and I'd certainly encourage you to get on that particular mode. The other thing you can do is, since this is a direct conversion receiver, you don't need to add very many more extra parts to make it into a transceiver. And you can you might be able to see here 2 final or 2 power transistors, BD139s, which you can very easily buy, very cheap. Anyway, that gives you a few hundred, I think it's about half a watt. But anyway, this is a JS8 transceiver. I haven't made a 2-way contact with it, but I have put out signals, and they have been received in northern New South Wales. So about 800 kilometers or more away with this particular thing. At the moment, I've got a switch on the front panel that switches between transmit and receive, but ideally you'd be wanting a Vox voice-operated relay system so you can take advantage of all the automated benefits that JS8 has to offer. And the software is to run all this is free. It's called JS8 Call, and there's improvements being done all the time. So if SSB and CW aren't your thing, then there's some great possibilities with QRP on the digital modes. So having talked about equipment, I've talked about options like commercial, secondhand, kit, or homebrew. Another thing that's pretty important is powering your QRP gear. A lot of it depends on how much space you've got, how much weight. Your main options, and probably the cheapest options, there's probably any number of clapped out sealed lead acid batteries looking like this that you'll see around the car park or whatever for sale. Problem is that they're quite heavy, so they might be okay if you're not carrying something very far, but alternatively, if you want something light, then consider another battery. It will cost you more, but it's a more modern approach, and you'll be thankful for doing so if you have to carry your equipment up a summit or something like that. Other battery options, nickel cadmium, okay, but limited capacity. Lithium polymer, they require special charges, and you have to treat them carefully, otherwise it might go bang. And or lithium ion, again, very lightweight type of battery, quite expensive, but you do need a special charger. The type of battery I use for a lot of my QRP, it's not the most compact battery. It only weighs about 1 kilo. It looks a lot like a sealed lead acid battery. It was quite expensive. I think it was like $150 or something. But anyway, it's a LiFePO4, and it's 7.5 amp hour, 12.8 volts, and it's been a really good battery for me for something like the FT817. It's got way more capacity than you'd need for most portable QRP of 2 or 3 hours. But these types of batteries are coming down in price. You might even find sellers at the field day today and be able to pick up something like this for a lower price. But thing you look out for, LiFePO4. And this one's 12.8 volts and 7.5 amp hours. The important thing as well when we're talking about batteries and power is a power budget. A lot of that depends on the transceiver you're using and also how much you're transmitting. Most of the time with QRP, you're spending on receive, maybe 80% of the time you're tuning around, listening, monitoring. So receive current consumption is really important. And that's where a specialized QRP rig can help, because something like the FT817, 818 is okay at 300 or 400 milliamps on receive. The Elecraft's draw, I think, about 150 milliamps. That's okay. But then you've got some other rigs like, that may be designed more for mobile rather than portable. They might draw a couple of amps on receive, and that can really drain your battery in no time. So yeah, for portable QRP, go with a transceiver that has a minimum, quite a small amount of current consumption. And just to put things in perspective, I've built homebrew receivers that draw just 2 or 3 milliamps. It was a very simple 2-transistor regenerative receiver, and that has still picked up signals thousands of kilometers away. So yeah, it's a lot of the commercial manufacturers don't necessarily have much of an imperative to cut their current consumption, so some of their gear can take a lot of power unless it's designed for portable QRP. So yeah, with your power budget, you basically guess what proportion of the time you're receiving, what proportion of the time you're transmitting, work out how much power, and then you can work out your battery capacity that you need from that. And make sure you allow a lot of extra fat. You don't want to be stuck up on a summit or on holiday or whatever and be running out of power. So take maybe double the battery capacity that you calculate you need. As a rough rule of thumb, with something like the FT817, assume about 1 hour of operating with per amp hour of battery, so or a bit less. So something like this 7 amp hour battery might keep you going for maybe 7 hours of fairly casual operating. If it's something a bit more heavy going, like a contest, maybe it would be only 5 hours. And that's another thing. I mentioned the receive current consumption of transceivers. Another thing is transmit current consumption. You can get on QRP if you turn your 100-watt transceiver down to 5 watts. That's fine. But monitor how much current it draws. Your 100-watt transceiver might draw something like 20 milliamps at 100 watts. But down at 10 watts, it might still be drawing, I don't know, 8 or 10 milliamps, something like that. It is horrendously inefficient as a QRP transceiver. Maybe it doesn't matter if you're just doing QRP from home, but if you're portable, then that's something to consider. Something like the FT817 draws nearer to 2 amps on transmit with 5 watts, and that's more efficient. Now, another thing is I would suggest, if you want to know a bit more about QRP batteries, there is a free article. It is right up to the minute. Even though we're still in February, you can look it up online on the ARRL website. It's in the March issue of QST, March 2020. They have a free article each month, and they've got good taste because their free article for March 2020 is all about choosing batteries for QRP. So when you get home, have a look at the ARRL website, have a look at QST, and see the free article on QRP batteries. Next point, and this is probably one of the important issues, antennas for QRP. A lot of people associate QRP with pretty poor antennas, things like magnetic loops, but it doesn't have to be the case. And some people try QRP and real compromise antennas and get quite poor results and maybe give up. Basically, with QRP, you can use any antenna you like, but you need to be aware of the losses and the trade-offs. If you're looking at 5 watts versus 100 watts, that's a difference in power of 13 decibels, or about 2 S points. So, you might be able to establish contact with 100 watts and then still be able to hear you with 5. But a lot of it depends on their local noise. If you're another SOTA station or in a national park, they'll probably still hear you. If they're in a suburban location, they might not. So signal to noise ratio is absolutely important on a receive for receiving. Now you can recoup some of the 13 dB loss between 5 watts and 100 watts from a good antenna or a good location, or you can just be lucky and be there at the right time and signals can fade up and down, and you might just be able to get a contact. Okay. I suppose there's so many different varieties of antennas. It's probably easiest if I talk about antennas to avoid. First of all, it's difficult to make an antenna that's a whole lot better than a half-wave dipole. But it's very easy to make one that's inferior. So take that as your baseline. There's no relationship between the cost of antennas and performance. You might assume that, oh, it's a bought antenna, it all looks shiny, it all comes in a nice packet with a lot of little bits and pieces that you can fold up really tiny. That's got nothing to do whether it's going to be a good antenna or not. In fact, some of the antenna things are marketed and they have quite high prices. They're designed to solve people's problems, most particularly people that don't have much space, but their performance might not be so good as an antenna. Especially if they go to a lot of compromises to cover multiple bands without tuning. Often there's compromises. So I'd avoid those sorts of antennas without delving further. Another thing I'd suggest you avoid, dipoles shorter than 3/8 of a wavelength, even if they've got tuned feeders. Like a G5RV on 80 meters is okay. That's about 30 meters end to end. That's 3/4 the length of a half-wave dipole. That's fine. But you go a lot shorter, and the impedances change. They get more reactive. The harder to tune in. Your efficiency drops off quite dramatically once you get to less than about 3/8 of a wavelength for something like a tuned feeder dipole. You might be able to have other options with that dipole. For instance, if you're going to use a G5RV on 160 meters, then you might tie the feed lines together and feed it as a vertical, and provided you've got a good ground system, then that can work okay. But yeah, generally speaking, very short dipoles are a significant compromise. You can go a bit shorter than half wavelength, but not a lot shorter. You start losing signal. Another thing I'd be looking very carefully at as an antenna to avoid, short end feds and verticals, especially if they've got a poor ground. Yep, your SWR might look fine. It might look good on the antenna analyzer, but that doesn't necessarily mean that it's going to be very efficient. You might have substantial losses still, especially if you compromise on the ground. You can get away with something like a half wavelength as a vertical. That will be okay. A quarter wavelength will be somewhat marginal if you're just trying to feed it with a little counterpoise without much attention to anything else. You go even shorter and the performance will be even worse. So that's just something. Another thing is antennas that come in these nice packages that have all these little bits like loading coils and traps and connections and all that. Especially if you're field portable, a lot of little parts that can go missing, especially if a thunderstorm comes over and you're having to pack up something really quickly. Very easy to leave stuff behind. So avoid that risk by having simple antennas with fewer parts. Another thing I'd suggest you avoid, antennas that claim small size, wide bandwidth, and high efficiency. Now, you can have two of those. You can have small size and wide bandwidth, but it won't be efficient. You can have wide bandwidth and high efficiency, but it won't be compact. Or you can have good efficiency. You can have small size and good efficiency, but it will not be. Its bandwidth will be very narrow. It will be a very high Q antenna, like some magnetic loops. So you can have two, but not three. So just be very suspicious of claims that say that you can do everything in multiple bands all at once in a tiny package. Another thing I'd steer clear of, especially if you're using light portable poles like squid poles to support your antenna, or even wires and trees, anything that's too heavy or complex. Yeah, always avoid complexity. Traps, loading coils, etc. They're just the thing to get snagged in trees. The tops of squid poles are often, you can see I've broken the thin top of mine. But yeah, if you've got antennas with traps and loading coils, that adds weight and that causes the pole to droop and the wire will sag. So if you can, try and stick with simple wires. The other thing I'd steer clear of is portable antennas with resistors for broadbanding. That's fine for their purpose, like outback communication. If you've got a 100-watt or something, Codan, and you just want to communicate a single hop, that's fine. And the other station you might be contacting might also be in the outback and have very little noise. But as amateurs, our needs are a little bit different. We often want to work DX, longer distances. A lot of the people we're trying to contact are often in suburban areas with a lot of noise. So you want to think about antenna efficiency. So I'd avoid the broadband type antennas with resistors. As for antennas I've used, a lot of them are described in various books. This is a book called Hand-Carried QRP Antennas. You can get it as an ebook that you can read on your Kindle, or as a paperback at great expense if you're watching this in Australia. It's a bit cheaper overseas. And there's a more recent book called More Hand-Carried QRP Antennas that's only just come out, and that's got even more. Anyway, sort of antennas described in here, things like end-fed half wavelength wires and an L-match. They can be really compact. Here's an example, something like this. I'll just give you a close-up of the antenna coupler. It's got 3 inductor settings, and a transistor radio plastic type variable capacitor, and a BNC that plugs straight into your transceiver. And here on a Dick Smith soldering iron reel is 20 meters of wire. No feed line, but this is the basis of a very simple QRP antenna. You might want to add a counterpoise on the other end. You don't need a separate antenna analyzer. You don't need a separate VSWR meter. The one in your FT817 or similar will be good enough. But yeah, this is a very simple portable antenna. It'll get you going as a half wavelength on 40 meters. It'll be a full wavelength on 20 meters, but you can still tune it up. And you might be able to cover other bands like 30 and 17 meters with this coupler. So yeah, if you just want something simple and light, then that's what I suggest. And you can use a squid pole like this, 8 or 9 meters tall, to support it. You have it like an end-fed inverted V with the squid pole being in the middle and the wire just sloping down. You tie one end off to a fence or shrub, and the other end goes into your antenna coupler. So yeah, probably not the greatest of antennas, but a great general purpose antenna. Will get you on several bands, ideal for SOTA national parks, and you might even work some DX occasionally. Another possibility is a full wavelength delta loop. You can choose what polarization you want. If you've got it's basically a triangle, 1 wavelength of wire. You've got the point at the top, so you can use the squid pole like this to support it. And then a third of a wavelength aside, and then about a quarter of a wavelength from the apex, or a 12th of a wavelength from the bottom corner. That's where you have your feed point. And if you do that, you'll get vertical polarization. And that is good for low angle DX type work. So yeah, vertically polarized delta loop can be good for 20 meters DX. If you're near the beach or have a timber pier, you can put that over the water and get some good results. And even though it's a wavelength around in perimeter, you can use an antenna coupler and have it operating on several bands. Again, you don't want to be using a antenna that is too small for your frequency, like an antenna like a delta loop for 20 meters. If you feed it with open wire feed line, that will be okay on 30 meters, where it's about 2/3 the full size. But I think you'll struggle on 40 meters. And you can go higher in frequency, like it would also be okay on 15 meters. Doesn't have to be resonance. That's a popular myth. Doesn't have to be resonant. You can have quite low losses if you use open wire feed line and just adjust it. Another possibility, a center-fed dipole and variance. What sort of variance? Well, you could, that's pretty efficient for a single band. But if you want multiple bands, like I think they did a survey on Summits of the Air a few years back, and about the most popular antenna was a linked dipole. The only problem with it is you have to lower it down and change your links on the tails of the dipole if you want to change bands. But it's efficient, It's a full-size dipole performance on each band you use. It's fine for maybe 2, 3, maybe 4 bands, but above that, you get so many links that it becomes awkward. And band changing can be a problem if you want to do it quickly, like during a contest. So you've got other possibilities for that. If you want fast band changing, you could use a open wire fed dipole with a balanced antenna coupler, and that can get you on multiple bands, be quite efficient, and allow fairly quick changing between them. There's other antennas as well. There's one called the bi-square, which I built one for 10 meters once, and it was huge. Another possibility is the half square. That's good for low band DXing if you want low angles of radiation for quite a small antenna. And people on the air often don't know what one is, so you're often explaining what it is. And it's basically a full wavelength of wire, quarter wavelength up, half wavelength across, another quarter wavelength down, a bit like a very fat inverted U. So you need 2 poles separated half wavelength apart. It's vertically polarized, gives you a bit of gain broadside to the wire, and that can work for 40 meters DX quite well, especially if you're near the water. As for antenna materials, well, you've seen a few already. There's a squid pole here, which you can get from fishing shops like Haverford's. Now, I just happen to be near a case I have for bits and pieces where I keep plastic bits of kitchen chopping board. Really easy to work with. You can just use a hacksaw and chop it up into little bits. That's ideal if you are making antenna insulators or even spacers for open wire feed line, or even parts of magnetic loop antennas. It's a very robust material, very easy to work with. And chopping board, quite new, can be fairly expensive, but if you look in second-hand shops, then you can get a few chopping boards and or even steal the one from the kitchen and use them for various insulators for antennas. Good for dipole centers as well. Overall, you have to go for something that's small and light, especially if space is imperative. You've got to save space and weight. So the thin hookup wire, like you see at JCar or whatever, is fine. When you're in JCar, make sure you have a look at the Australian Ham Radio Handbook, as that's in all the stores. So grab your own copy there and grab some wire and a few other bits and pieces for your portable antenna. Then there's some things to avoid, especially if you want your portable station to be really light. Avoid coax cable, mainly on HF, bulky antenna couplers, bulky VSWR meters. If your transceiver has something inbuilt, then you don't need a separate one. Heavy balance, again, you can do without. Antenna analyzers, leave them at home. Question every gram in your portable station. The question to ask is, does it add to your signal or not? If it's an external accessory like a bulky clock or a Morse key or whatever, then that doesn't add to your signal. So leave that at home. On the other hand, if it's a taller mast, like a bigger squid pole, a better antenna, then yeah, consider taking it along, as that will improve your signal. Means to support the antennas, a bit of fishing line and sinkers, but people, especially if you're in a public place, people don't like the idea of someone throwing bits of lead around, so that might be a bit antisocial. If you live by the beach like I do, the trees, if they're there at all, they're not very tall, so always taking this squid pole. 8 or 9 meters is a good length, but it is a little bit big to fit in airport luggage. But there are versions of squid poles that are only 5 meters, that are like half the length, and they can still extend to 5 meters or even more. That's a possibility. Velcro strap is great. Always have something like wire, string, Velcro strap or whatever to tie to your fence, railing, pier or whatever. I have tried some antennas, QRP with kite antennas. You can get some great results. Depends very much on the wind. At the moment, looking at the window, it's dead calm, so good thing I'm not outside today trying a kite antenna. But a single kite can easily support 40 meters of wire, and that you can get great band results on a band like 160 meters. You don't need any more than 5/8 of a wavelength of wire with a kite antenna. You do need a large open space. Safety is really important. You don't want the kite to come down on other people. The other thing with elevated wire antennas is you might, even though there might not seem to be thunderstorms, you may get static. And I've blown up transistors in homebrew receivers because of the static voltage. So you might want to put a resistor, a bleeder resistor of a few 100k ohms from your antenna connection down to earth to help with that. Okay. Matching the antenna. You can feed a dipole directly with coax. You can get away without having a bulky balun. You could use RG174, fairly thin coax. I'd be a bit worried about the losses for VHF with that. A small antenna coupler like this, though, takes up much less room than a roll of coax, and it's super light, allows multiple bands. So that's probably an option, if the better option than taking coax, if you're just using a wire like this. As for antenna couplers, you might be baffled about all the different types you can get. A very simple L match like this is about the simplest and overall the one I'd usually recommend. A pi network is the same, except it's got an extra variable capacitor. Some people used fixed ratio broadband transformers, like 9:1 or whatever. Another possibility is a fixed ratio but tunable type transformer. Have a look on the AA5TB's website. AA5TB. There's a lot of information about that, and something like that could be handy for a small end-fed wire. Personally, I prefer L matches. I like the assurance of being able to tune up an antenna properly, get it spot on. And some toroidal materials may be lossy. There might be issues there. And with QRP, that's another thing. Whereas with high power, a lossy component will heat up, might even get red and explode and shatter into a million pieces. But with QRP, you can sometimes be oblivious of losses because your output power is low. Things might not warm up very much, and things can be lossy without heating up. So just be a bit wary there. As I'd suggest avoiding automatic antenna couplers. They're expensive for what they are. They don't match as wide a range of impedances as a manual antenna coupler. They don't contribute a single decibel of signal. They might use batteries and they can run out at the most inopportune moments and they draw power. So yeah, save your money, save your weight, and have a taller mast or better antenna instead. Now we've covered equipment, we've covered batteries, we've covered antennas. Next thing, making contacts. Now, some people don't have a lot of success with QRP. Could be due to a lossy antenna, could be a bad choice of band. Like right at the moment, for instance, 10 meters could be touch and go. We're at the tail end of the summer sporadic E season. You might get some great signals from Tasmania coming in right at the moment, or you might not. You might be trying 160 meters in the middle of the day. In some areas will be okay. Here in Melbourne, where there's a coffee break net every day at 11 a.m., then you might have some activity on 160 meters in the middle of the day. So really depends on a lot of listening and checking activity patterns. Poor operating is another thing. A lot of people don't persevere enough. First thing, overall, now there's a lot of information about operating in my book, Minimum QRP. There's no circuit diagrams. There's a lot of information on the various ways to get contacts, and I think it's absolutely critical. First of all, tune the band first. Just get an idea of the general conditions, whether there are signals that you normally hear. If there are people talking, get an idea of their call sign, where they are, and where the propagation is open to. Also take note of beacons. 10 meters has a lot of beacons, between 28.2 and 28.3. A lot of the Australian beacons around 28.26 plus or minus 10 or 20 kilohertz. And on other bands like 14 megahertz and up, there are beacons like 14.1, 21.15, a few frequencies like that. And if you listen for 10 minutes, there are beacons all around the world that identify all on the one frequency. So you can get an idea where the band is open to. That's your first pass of tuning the band. Next thing you do, be a bit more attentive. Particularly listen for stations calling CQ, about to finish a contact, or making very quick contacts, because all of those present opportunities for you to call stations that you know are listening. That's important. Your chances of contacts are much better then. Best ways to get contacts: replying to CQ calls is good if there's people calling. If there's no one calling CQ, next best is listen for contacts about to finish. Some people might take 10 minutes to say 73. Other people might finish off fairly quickly, but just get an idea of contacts when you tune across that are about to finish, because they are often really good opportunities to call one of the stations involved. They'll probably still be listening and you'll be able to get a contact. The other option is that if there's no one about to finish or no one calling CQ, then you can start calling CQ yourself. Now, timing is really important. With QRP, you can't afford to be transmitting over the top of other people. On the other hand, you want people still to be around and listening to maximize your choice. In the minimum QRP book, I talk a lot about frequencies that are cold, where no one's listening, frequencies that are warm, where people might still be listening. And again, you've got to pick a warm frequency and have a great maximize your chance of being heard. Then when you establish contact, the only first thing is you have to make sure the other person has got your call sign right. They might volunteer all this other information, like their weather, the signal report, how the day has been, all that. Do not do likewise until you have got your call sign across. The contact is not valid unless you've got a successful exchange of call signs. Next, your signal report, then your name, QDH, whatever. But main thing is got to get the call sign right. That's the basics. Frequency agility. Frequency agility is king. You must find and call people rather than expect them to come to your frequency. Your signal might be weak. It might be buried under the noise. Whereas if you've got someone that is just finishing a contact, they might still be listening. Even if your signal is a bit below, is not quite fully readable, then people are always curious about weak signals. So you might still be in with a contact. They might ask for a repeat QRZ, and then you slowly repeat your call sign several times. With any luck, conditions might pick up. The interference from next door might go away, and they'll hear you, and you'll be able to get a contact. Now, as to conditions, are they really that bad? Yep, DX over 3,000 kilometers is harder, but at this phase of the solar cycle. But there's still a lot of things you can do. You can still work DX with digital modes. I mentioned FT8 or Js8 can be very successful. There's a thing called PSK Reporter that you can look and see where you're being received. Js8's got some nifty features where you can look at you can send commands to stations that can hear you and get an idea of what they are hearing. You can leave messages, have keyboard chats. There's all sorts of interesting things there. You can also use, despite the low sunspot numbers on bands like 20 meters, you can still work grey line DX early in the morning or around sunset on bands like 3.5 or 7 megahertz. Grey lines, open all the time. It might only be open for an hour or half an hour at those times, but you can often have some long distance DX, even with QRP. So 83 to 20 meters, you can still work 3,000 kilometer type contacts. Sporadic E on 10 and 6 meters, that is not affected by the solar cycle at all. In fact, some of the last couple of years, summers worth have been really good for 6 and 10 meters sporadic E. And then there's the whole world of VHF, UHF microwaves that's not affected so much by the solar cycle. Your sporadic E, your tropospheric, all your other things that you can succeed with QRP. As for another possibility is stuff like HF pedestrian mobile.
I've probably gone over time, so I won't talk too much on there. There's a few videos and a section on my website, vk3ya.com, on all that. But basically, your two main antennas you'd use would be a magnetic loop like this. This loop is something that I call the summer loop. It's 40 centimeters in diameter. It's 3 meters of aluminium that strip that you can get from Bunnings. It's got a little variable capacitor at the top. Now, you're all at a field day, so make sure you look around for variable capacitors. They're really, really useful. This type is a beehive trimmer. It's got a maximum capacitance of 50 picofarad. That is somewhat rare. They're most commonly 25 picofarad. So, buy 2, 3, 4 of the 25 picofarad ones, and you can put them in parallel. You can put 2 in parallel and still make an antenna like this. So something like this is a great portable antenna for pedestrian mobile. It goes from 21 through to over 50 megahertz. So I mainly use it for 6 and 10 meters. I've had contacts into Europe on 10 meters with it, but mostly it's 10 meters. If you've worked me 10 meters pedestrian mobile or 6 meters pedestrian mobile, it's probably while I've been using this antenna. Really light, easy to carry. I've also got another magnetic loop, which is a bit bigger. It's about 90 centimeters in diameter, and that works fine for between 7 and 28 megahertz. So I've had good pedestrian mobile contacts with that, even into the United States on 20 meters a few years ago. Another possibility, especially if you're near the beach, is a vertical on a backpack. You can get the light grid poles that collapse down to about this long, about 60 centimeters. They extend up to about 5 meters, and 5 meters is a good length. It's a quarter wavelength on 20 meters, so that's good. And it will work okay on 30 meters. On 40 meters, it won't be so good. So what I've done is I've put a loading coil about halfway down that antenna that I'll only switch in for 40 meters. Anyway, that is an antenna that I called the Raid Tenor. It's described in my antenna book and on my website, and there's a lot of demonstrations on my YouTube channel. But that is a good antenna if you're operating pedestrian mobile. It does, however, require, particularly on 40 meters, for you to be walking in the water. Your ground thing is making contact with salt water, and that greatly improves your station's performance versus just a wire just trailing along the sand. I do use an L-match antenna coupler as well with your 5 meters of wire, and that works quite well. So that's I'm pretty close to the end. Just to summarize, QRP works with all facets of amateur radio. The equipment is plentiful and cheap. It's probably a lot cheaper than it was 30 years ago. Operating technique is really important, and there's a huge variety of activities you can do with QRP, even at the moment when there's not much happening with sunspots. For further information on QRP, I'd strongly suggest there's the VK QRP Club. It's $15 a year membership, and you can get their magazine. It's 4 times a year. It's called Low Key. Also, look up the VK QRP Club on Facebook, and there's a good group there. More information, my website, vk3ye.com, and my YouTube channel, which is what you're watching this on, youtube.com/vk3ye. Then there's various books. This one's called Minimum QRP. It's been really popular all around the world. Something like 3,000 or more have been sold. You can get it as an ebook that you can read on a Kindle, but it goes into a lot of the topics that I've covered today, but much more detail. There's a lot, particularly on operating techniques of getting contacts, which could be useful even if you don't operate QRP. Even if you're operating DXing with 100 watts, then the things in here can be useful. There's also antenna books. I've mentioned this one before, hand-carried QRP antennas. It's been super popular, and the new book that's come out, more hand-carried QRP antennas. So there's a lot of material on antennas there. The other thing that's important if you make sure you stay around for the drawing of the door prize, the Australian Ham Radio Handbook. It's a general guide to amateur radio in Australia. We haven't had such a guide for something like 30 or 40 years. It was the original one back then was written by Dick Smith. So I'm very pleased and very thankful that Dick Smith himself has written the foreword for this book. So there's a lot of information. It goes a bit beyond the Amateur Radio Foundation license manual. There's a lot of practical information on getting on air, a lot of Australian-specific information about amateur radio activity, frequencies, bands, facets of amateur radio, where to find information. So yeah, it's Australia's own Ham Radio Handbook. If you're not lucky today with the door prize, go into JCar and pick one up for $24.95. Or if you're more into ebooks and Kindles, then jump on my website, follow the links, and you can get an ebook version. So that brings us to the end. I will now take questions. First of all, I know that there's people outside of Wyong Field Day listening and viewing, but we'll first of all see if there are any questions from people at the Wyong Field Day. Maybe put Wyong or W before your question, so I know that you are at the Wyong Field Day, and I've got as much time as you need to answer any questions. And if you are watching, there's a section on YouTube where you can just type in questions. If you're maybe if you're watching at Wyong, get out your mobile phone, have a look at YouTube, and I'd be. But in the meantime, I will have a look at. There are some comments that were made during the video. So there's. I'll answer them. QRP and AM mode. Yep, AM is less efficient than SSB, but it can be good fun. Okay, from the Central Coast Amateur Radio Club, we had an internet issue, but no questions at that end. So I'll stand by. So thanks for that. I'll stand by a little bit longer in case there are questions for others that might be watching this at home, maybe other parts of Australia. And KB1QZH, I'm at Wyong. Well, make sure you snap up lots of good bargains. My question is earlier in the chat. You might want to ask your question again. Do I FT8 occasionally? I must say it's it's very good for testing things. Occasionally I'll have a lot of a few contacts, but I wouldn't say I'm a FT8 fan. From Matthew Jones is a question: any luck with digital modes, FT8, etc. on VHF? I have had a few FT8 contacts, I think mainly on 6 meters. Don't think I've had any on 2 meters. I think, however, I have done quite a bit of whisper on 6 and 2 meters, and yep, definitely had a lot of luck there. Even when trying indoor antennas and things, I've been picked up by 400 kilometers or more distance. So yep, definitely digital modes on VHF can be great. And there's another mode, I think is it FT or JT144. Anyway, I forgot what it was called, but I did a video of it where it's basically optimized for meteor scatter. So I just had my HF antenna connected on 6 meters, and I knew there was a meteor scatter session going around 6 a.m. in the morning. So I left the rig on, and I decoded signals from VK4 like that's like 1,000 or 1,500 kilometers away. So yep, there are some great digital modes for VHF, meteor scatter, and yeah. And PU3HAG, can you share experience with counterpoise and squid pole vertical? Do I use a dedicated wire? No, I generally don't. I use whatever I can find. Quite a few videos where I just go portable, often use just a half wavelength or whatever, and have reasonable success. KB1QZH, Sydney apartment with micro BitX. Need an antenna. Well, first thing is get a portable setup, like the NFED 20-meter wire and L-match antenna coupler. Go portable on nice days. As far as operating from home, windows open wide. Oh, 26th floor. Well, you've got some great potential there. I'd definitely investigate 2 meters SSB, with that sort of height, or even 2 meters digital modes. For HF, maybe drop something, a wire down and have an L match or something, and maybe use something like a fishing pole to hold it out the window. So, yeah, that's quite a few antenna options. Okay, I've almost talked myself hoarse, so I'll just see if there are any more questions, and we'll finish up. Adam, do you like Z-Match antenna tuner? Yeah, no, they work fine. I haven't done a head-to-head. That's from Adam, head-to-head comparison, but yeah, I have built one or two and they seem to be okay. There's one, there's one on the website, VK5BR. Look up VK5BR's website. Got a lot of technical ideas, and including Z-Match, some simple Z-Match antenna couplers. So yeah, great. And thanks from the Central Coast Amateur Radio Club. Good luck to those watching at the club, and good luck in the raffle for the Australian Ham Radio Handbook. And if you don't win, then pop into JCar and get your own a copy for every radio club or shack needs one. How do I manage the sand on the beach? Well, I suppose one has to try and keep it out from things. I don't always succeed. If you've seen some of my videos with the FT817 and the sand encrusted in the display, well, it seems to work fine. But some other rigs are less robust than the FT817, like the Ellicraft. I wouldn't spend lots of money on that and have it all sand encrusted. And there's another reason why I rarely operate digital modes while portable. I keep my computer a lot tidier than my rigs. So yeah, that's my question on managing the sand. So thanks all for watching, and I'll end the stream, but you'll be able to have a look later on if there's anything that you've missed.